definition, you will be tested on it on a simple example. You have to remember how to calculate it, but no, we are not going to use this formula moving forward because we have shortcuts. Okay. So in 1.5, we're going to start learning differentiation rules. So here's the first differentiation rule. So let's say I have f of x equals 5. Just a number. What do you think is the rate of change of 5? Or any constant for that matter. You have $5 in your pocket. You don't do anything with it. You don't buy anything. You don't add money to it. So I'm asking you, in that case, what is the rate of change of a constant?
0.
Of course. Thank you so much. The rate of change, f prime for a constant. So f prime of x, I'm sorry, I want to write f of x is a constant, means f prime of x for that constant is 0. So that's the simplest thing to remember. The derivative of a constant is 0. Okay. Now let's differentiate a power. So let's say the next rule, so this was the first rule, here's the second one. So let's say I have x to a power n. How do I find f prime of x? Very simple rule. I bring n down and I multiply by x, removing 1 from n. So how do we differentiate as an example? Let's say x to the third power. Can anyone use the rule and tell us how to differentiate x to the third?
Would it be 3 multiplied by x to the second power?
That's it. So 3 times x squared. Perfect. That is indeed the case. Now, there is one special function, I would say, which is the square root of x that I would like to discuss. How do I find f prime of x? Just for the square root of x, because for others, this procedure, the shortcut will not work. But for f prime of x, this is our question. Remember, the square root of x can be written as a power. Can anyone tell us what is the power for the square root? What power do I raise x to that represents the square root of x? It's another way of writing the square root of x. What will that? I'm sorry?
1/2.
Excellent, brilliant. Thank you so much. So therefore, I can use the same rule because it's a power. So then from here, f prime of x will be, I bring down 1/2, I copy x, and from 1/2, I subtract 1. Well, that's negative 1/2. 1 minus 1/2, I'm sorry, 1/2 minus 1 is negative 1/2. So it's better if you remember this, the shortcut, which is 1/2 divided by the square root of x, and never apply the power rule on the square root of x. On anything else, yes, but it's a waste of time. And you will.
Another example of that one.
The square root of x is only 1. There is no other example with the square root of x. I can give other examples with some numbers, some expressions in front, and so on and so forth. But this is a formula, like this one, like this one. Now, if you want to look at the cube root of x, then we don't have a shortcut for the cube root of x. You have to change it to x to 1/3. And you have to use the power rule. So f prime of x for this function will be 1/3 times x to 1/3 minus 1, which is negative 2/3. You have no choice. For any other index, you have to use these steps. But for the square root of x, please use the shortcut. It will save a lot of time. Do you have to? No. You can always use the product. I'm sorry, you can always use the power rule for any radical. But I recommend just for the square root of x, don't use the steps. Just go directly to the f of x, the square root of x. F prime is 1 over 2 the square root of x directly. I highly recommend that. The other thing that I would like to add here is when we differentiate, I'm on page 8. So when we differentiate the sum or a difference of two functions, so if I have, or more than two functions, any number of functions, if I have addition or subtraction and I want to differentiate, very simple, it's f prime of x plus or minus g prime of x. So these are our first rules, shortcuts, not the difference quotient, which is very tedious as you've noticed. So I'd like to go to 154 and let's practice. Okay, so it says find the derivative. Now, what is this notation? Okay, let me explain that. So f prime of x is one notation for the derivative, and the derivative of y, which is f, the same thing, divided by the derivative of x is the same thing. You can use this notation or this notation. Sometimes this is more convenient than this. Why is this sometimes more convenient? Because I can tell you find f prime of 1. But if I want to use this notation, it's a little bit more cumbersome because I have to say dy over dx evaluated when x is 1. More writing if you want. But they are the same. This is called the Leibniz notation. Okay? Not very important. So they mean the same thing. This is the derivative, and this is the derivative of f with respect to x. So dy over dx, the derivative of y with respect to x. Okay? Although, and I don't want you to read it as dy over, as the derivative of y over the derivative of x. Sorry. So it's the derivative of y with respect to x. So f prime of 1, if I want to evaluate, but if I want to say, how do I evaluate this with 1, it's a little bit more cumbersome to write. It's dy over dx evaluated when x is 1, because there is no way to put parentheses. Okay. So it's the same thing. It's just a different notation. Interested in this set, or we move on to the next set?
Let's just do one
yeah.
example.
Yes, yeah. So let's look at 19, for example. In 19, we have y equals x to the third plus 3x squared. So we want to find another notation. The same thing here is y prime. So you can use y prime. You can use y prime. You can use dy over dx, whichever you prefer. You can use f prime of x. They're all the same. So can anyone, you already told me the x cubed. So this was 3x squared plus. For 3x squared, we bring 2 down, but we have to multiply it by 3. And then subtract 1 from the power. So what is 3x squared prime?
6x.
It is 6x. That's it. Done. Okay. Now, for example, if you give me 21 and you say work on 21, and this is y equals 8 to the square root of x, I will not use the power rule. So for this one, either dy over dx or y prime, I will say 8 over 2 the square root of x. Done. Because I know that when I differentiate the square root of x, I get 1 over 2 the square root of x. I don't want to waste my time with powers. It will be a waste of time. And I will simplify, and I have 4 over the square root of x. Now, if it's the cube root, the fifth root, and anything else, yeah, I get stuck there. I have to I have no choice. Okay, so let's practice some more. That's another way of writing it. It's the same thing with dy over dx. They are getting fancy. There is no need, but you need to be to be able to read this. So this is the derivative of y with respect to x. This is the derivative of y. Instead of writing y, they put the function in there already. So we want to choose, or we look at the next page.
Can you see number 30?
Which one?
Number 30.
Number 30, yes, of course. Let's look at number 30. And 30 and 154. So these were 154, 154. Okay, so you said the derivative of the cube root of x plus 4 over the square root of x. Perfect. In this situation, I have to rearrange everything first. So d over dx, I will change this into x to 1/3, and I have to change this into x to negative 1/2. I have no choice. I can't differentiate that otherwise. So the cube root of x, first of all, is rewritten as x to 1/3. Then I copy plus and 4, and 1 over the square of root of x changes into x to negative 1/2. X to negative 1/2 is 1 over the square of x. And now I can differentiate. So I bring down 1/3. I multiply by x. I subtract 1 from 1/3. 1/3 minus 1, negative 2/3. Now, I will not write plus, because when I bring down negative 1/2, 4 times negative 1/2 is negative 2. I copy x, and from negative 1/2, I subtract 1. Leave it alone. It's good enough. Any questions? Any questions here? Any questions? I want you to understand how important this type of question is. It comes back again, but this time we don't have to use the definition of the derivative function, the one with the limit of the difference quotient. We have the shortcuts. We have the differentiation rules. Okay, would you like to find the equation of the tangent line again, this time with differentiation rules, or we move on to a word problem?
Can you do number 57?
Yes, with pleasure. Where is 57? I see it. Okay, in 57, we have f of x equals x squared minus the square root of x. Which of the points you prefer? It doesn't matter. They're all the same.
B.
B, 4 comma 14. Perfect. So, of course, this is a shortcut. We can immediately find f prime of x as 2x minus 1 over 2 the square root of x. Do not change. Use the shortcut for the square root of x. Of course, I have y minus y1 equals the slope times x minus x1. This is 4, and this is 14. I only need to determine the slope, which is f prime evaluated at 4. I only have to evaluate f prime at 4. 4 times 2 is 8. The square root of 4 is 2 minus 1/4. 31 over 4. So y minus 14 equals 31/4 x minus 4. It's not finished, but let's stop for a moment and see if you have questions. Is this okay? much faster because we are using a shortcut. X squared prime is 2x minus, I already know the square root of x prime is 1 over 2 the square root of x. Boom. No calculations needed. I know that the x value is 4. 2 times 4 is 8. The square root of 4 is 2. 2 times 2 is 4, negative 1/4. 32 minus 1, 31 over 4. So now I distribute 31/4 x minus 31, but plus 14. So y equals 31/4 x, and minus, is this 17? Correct me, please.
Yes.
Perfect. Any questions? Okay, let's take a look at a word problem. What about the growth of a child? The median weight of a boy whose age is between 0 and 36 months is approximated by this function, where t is in months and w is in pounds. Okay, pounds per month. The rate of change will have a measurement unit coming from a ratio as a measurement unit, coming from the y value over coming from the x value. Okay, so let's see what they want. The rate of change, use this model to approximate the following. The rate of change of weight with respect to time. The rate of change of weight with respect to time. That is w prime of t. That is the rate of change. It's not the average rate of change. For the average rate of change, they have to give us 2 points. They don't. They're asking to find the rate of change of weight with respect to time, which means w prime of t. So 87 on 155. So w of t equals, I'm going to put it in the correct order, 0.000758 t cubed minus 0.0596 t squared plus 1.82 t plus 8.15. So in part A, they want us to find the rate of change. Not at a specific value, the rate of change, which means w prime of t. Okay, I have to multiply this by 3. What do I get? 15, 17, 21, 22. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. T squared minus. Let's see what I get now. 9 and 1. 1, 1. 1, 2, 3, 4. 1, 2, 3, 4. Perfect. T plus 1.82. This is the rate of change. Okay. Part B. The weight of a boy at age 10. It doesn't say the rate of change at age 10 months. It says the weight. So the weight is just W of 10. That's all there is. So the weight W of 10 is part B. And you know me, I'm too lazy to plug this in. So 0.00030758 t cubed, and then minus 0.0596 t squared, and then plus 1.82 t, and then plus 8.15. And now second and table, I want 10. Give me the number. So 21.148. 21.148. Let me just go back and make sure that I punched in everything correctly. 3 zeros, 758, correct. 0.0596, correct. 1.82. And what was 8.15? Okay. So back to the problem. The weight of a boy at age 10 months. Okay. I'm happy that the answer is correct. Good. Okay. The rate of change of a boy's weight with respect to time at 10. So again, I have to write pounds before part C. Now they want the rate of change of a boy's weight with respect to time at age 10. So I'll go to y equals, oh, I'm already there. And I'm going to enter the derivative now. 0.002274 t squared minus 0.1192 t and plus 1.82. I already have it. It's already there. It's the next function. So the rate of change is 0.8554 measurement unit. So this is W prime at 10. Measurement unit, 0.8554. Can anyone give us the measurement unit for the rate of change at 10 months old?
Pounds.
The rate of change has two measurement units. One always, it's a ratio. One always coming from the y value over the one always coming from the x value.
Pounds and month.
Pound per month. Yes. Pound per month. Exactly. The measurement unit is always the measurement unit for the rate of change. Just always remember, you can never tell me that you're driving at 40 miles. You have to say you're driving at 40 miles an hour because that is the rate of change of distance with respect to time. So what is left for next time is 1.6, 1.7, and 1.8. And then the next time we review. So everything from R.1 through 1.5 has to be completed before class on Tuesday. Please, I'm begging you. Okay, so we completed